All right, so it says Module 8 Homework 1 Notes, which is talking about domain and solving rational equations. Again, what does the word rational equations mean?
Radical.
Close, not radical. Close. Rational. What have we been dealing with this whole time?
Rational. Fraction.
Fractions. Thank you. Like pulling teeth. Rational means fractions.
Okay.
Oh, yeah.
Oh, yeah.
Okay. But you don't know how they drew that conclusion in math. Like, a rational thought. What's that in math? A fraction.
Because it's irrational. So rational is something that, how would you explain it in English? Like something that makes sense, something that's, if it's like a rational thought, it's somewhat of like a...
It's proper.
Proper. Yeah, that's a good way to put it. It's proper. So like if it's a fraction, it's proper. You know, like 1/2 is 0.5, you know, that stuff. If you have something that's irrational, it's something like pi. Pi goes on forever. I can't write it as a fraction. I can't write it pretty. So it's irrational.
So one
See
thing
it?
is irrational.
Yeah.
Even though it's irrational.
Okay. So anyway, so in this section, we're going to find the domain of a rational expression. We're going to understand why the domain restrictions matter for solving an equation. We're going to determine if we can clear the denominator. Then we're going to solve the equation where the variable appears in the denominator. So, looking at this, we did questions like this on test 1. So it's kind of just going back and closing the loop. We did something like this on test 1. It's going back and closing the loop. And we're going to add just a little bit to it because we are better than we're better mathematicians than we were on test 1, hopefully. All right, so finding the domain of the rational function. F of x equals 7x minus 8 all over 9. So before we even answer this question, what does it mean to find the domain? What is the domain of a function?
The x's.
The x values, good. So all possible x values. So it's basically saying, what could I plug in? What could x be? Going back, again, I just told you the answer. What is a rational function?
A real fraction.
A fraction. Yeah, it's real. A real fraction.
A real fraction.
It's a fraction.
Fancy ways of writing fractions. So when are rational functions, when are fractions undefined?
They're divided by 0.
When they're divided by 0, coming in strong in the back. When they're divided by 0, thank you. So, when our denominator equals 0. When it's divided by 0, when our denominator equals 0. The denominator means the bottom of our fraction. So notice, again, going back to test 1, we're going to write the domain as set notation. Remember, set notation is our curly brackets, the set of x, such that x is a real number, and x cannot equal whatever. So let's go back to our original problem. It says find the domain. Notice, this is straight from my math lab. I copy and pasted it, so this is what the answer choices will look like. So if we have f of x equals 7x minus 8 all over 9. So we have to find out where are the problems. What can x not equal? So looking at what we just talked about, where are problems? When the denominator equals 0, right?
Yeah.
So our denominator,
Well, the first part of the question, the denominator knows it equals 0.
pause that thought for 1 second. That's perfect. So our denominator cannot equal 0. So notice it's not equals. Equals with a line through it. So what is our denominator in this case? 9. 9 cannot equal 0. Will 9 ever equal 0? No, that will never equal 0. So there's no problems. So x can just be any real number. So B.
Okay. I see.
9 will never equal 0, so no problems. We can plug in whatever we want for x, any real number.
So there's no x in the denominator, then it's always going to be a.
It's always going to be b. Yeah.
Okay.
That's what you meant, yeah. Honestly, it's not very likely, but yeah. All right, so if there's no x's in the denominator, going back to what he said, there's no x's in the denominator, so that means it doesn't matter what we plug in for x, it's always going to equal 9, so we're never going to have any issues with our domain. I can plug in whatever we want, any real number. So boom, the domain is x such that x is any real number. Question so far? So let's do another example. So find the domain of the rational function s of t equals t squared plus 5 all over 5t. So it's a fraction. So we know where our fractions, our denominator cannot equal 0. What is our denominator?
5t.
5t. So 5t cannot equal 0. We're trying to get t by itself. How do I do that? Divide by 5. So t cannot equal 0 divided by 5, which is 0. A lot of people get confused with that. Just plug it into your calculator. 0 divided by 5. Boom, 0. If that freaks you out, use your resources. So I know that t can be whatever it wants, it just cannot equal 0. So going back, we have our set of t such that t cannot equal 0. Our little shorthand set notation. In my math lab, just like the previous problem, you just have to put in 0. It already has it, the template already there, the format already there for you. Makes it easy.
Is that really what these first ones are like? I guess it gets more complicated.
Yeah. The first ones are just find the domain, and then we're gonna use this domain and show you why we are doing this. So next one, find the domain of the rational function f of x equals 6x all over 8 minus x. Looking at this, we see that there's a fraction. So we know our denominator, the bottom of our fraction, cannot be 0. Our denominator in this case is 8 minus x. So 8 minus x cannot be 0. Solving this, getting x by itself, I need to move this positive 8 over to the other side. So I can subtract 8 from both sides. That way 8 minus 8 goes to 0 and cancels out. We're left with negative x. Cannot equal 0 minus 8, which is negative 8. And last but not least, getting x by itself, I can get rid of that negative by dividing both sides by negative 1. That way the negatives cancel each other out. We're left with x cannot equal negative 8 divided by negative 1, which is positive 8. So x cannot equal 8. So our domain is the set of x such that x cannot equal positive 8. And that is our answer in set notation. The set, using our curly brackets, of x, that's our variable, such that x cannot equal positive 8. Next page. Finding the domain, again, of the rational function of the fraction r of x equals 7 plus x. 7 plus 7x all over x cubed plus 5x squared plus 4x. Again, it's a fraction. So we know our denominator cannot be 0. Our denominator in this case is x cubed plus 5x squared plus 4x. So that cannot equal 0. Looking at this, I see GCF, greatest common factor. They all have an x in common. So let's factor or divide out an x from every single term. And we're left with x squared plus 5x plus 4 cannot equal 0. So x is already done for us. We now need to factor this inside. Thankfully, it's in standard form for us, ax squared plus bx plus c. So that way we can see that our a value in front of x squared is positive 1, b in front of x is positive 5, and our constant on the n is positive 4. So we are looking for two numbers that multiply together to give us A times C, so 1 times 4, which is 4. And the same two numbers to add together to give me B, which is 5. So positive 1 and positive 4. 1 times 4 is 4. 1 plus 4 is 5. So thankfully our A value is 1, so I can go straight to my factors using our shortcut. If you don't want to use your shortcut, that's totally fine. Just factor by grouping. Our variable is x, and in the blank we have positive 1, we have positive 4. Now don't forget to bring down your GCF of x out front. So we factored it. Now we're going to solve for x by setting each factor not equal to 0. So x cannot equal 0. X plus 1 cannot equal 0. And x plus 4 cannot equal 0. X cannot equal 0 is already solved for us. X is already by itself, so that's one answer. Subtracting 1 from both sides, we get another answer is x cannot equal negative 1. And lastly, x plus 4 cannot equal 0. We could subtract 4 from both sides and get x cannot be negative 4. So our domain is the set, using our curly brackets, of x, because our variable is x, such that x cannot equal 0, negative 1, and negative 4. So x can be any real number, it just cannot be 0, negative 1, or negative 4. Now kind of switching it up a little bit, what's the difference between an equation and an expression? An equation has an equal sign, and an expression has no equal sign. That's it. So looking at our next example, determine whether the following is an equation or an expression. There's an equal sign here. So it's an equation, meaning we can solve it. We can get whatever x equals. Done. The next one, determine whether it's an equation or expression again. X over x minus 9 plus 8x over x plus 9. There's no equal sign. So we know this is going to be an expression. We cannot solve expressions. I can't find x equals because there's not an equal sign. So all we can do is simplify expressions. Given the following equation, find the LCD, the least common, I don't know how to spell obviously, the least common denominator. So looking at this, if I have 6 over z minus 2 equals z over z squared minus 4 plus z over z plus 2. Exactly the same thing we did before. Yeah, go for it.
Would you like me to give you the LCD?
Pause that thought for a second. Z plus z minus 2 can't be factored. Z squared minus 4.
Difference of perfect squares.
Difference of perfect squares. Z squared is z times z. One's positive, one's negative. 4 is 2 times 2. Z plus 2 cannot be factored.
Why did they give us C's? They look like 2.
I know. Of course, they give you z's and 2's together. All right, so our LCD is z minus 2 times z plus 2. Good, thank you. So looking at the left-hand side, going from left to right, z minus 2 has to be in there. Z plus 2 has to be in there. Z minus 2 is already there, so I don't need to write it again. Z plus 2 is already there, so I don't need to write it again. Boom. That's it. Yes, sir.
So with your experience with this section,
Okay.
are you going to stay with this pattern that I keep seeing, or are they going to throw in, because
What's the pattern that you see?
in the companion study and quizzes, you're not going to get that middle one. You're going to get something else that you break up, and then you're going to have 4 different answers instead of this simple 2-answer question.
They usually correlate together. Usually, not always. There are some times where you get to put 4 things together, but usually not. Usually it's similar to this. Promise.
I'm just saying, because if you're good at factoring, you notice that's a perfect of squares.
Yes, you kind of have a hint because these other 2 things are already there. So you kind of, so definitely use the problem to help you. Yeah, so this should, not always, because there's times that they know people think that, so they throw tricks in there. Yeah. But usually because we had those two factors there, yeah, usually this is going to factor into that. Usually. Yep, that's a good pattern. That's a good generalization to make for this section. All right, so with that being said, let's go on to the next one. So this is putting it all together. So we have to solve the equation. So notice there's an equal sign. It's an equation. So our final answer should be z equals. Our final answer should be z equals. So notice the function has restrictions in the domain. So for these, we have to find the domain first. So we're going to find the domain, figure out what z cannot be, go through, find what z does equal, and then make sure that it actually works and is able to be that answer. All right, so with that being said, let's find the domain first.
0.
Yes.
Equals 0.
They're fractions, so our denominator cannot equal 0. If you miss this step, you will get points off. Promise. Because you're not doing the whole problem. So our first denominator is z. So z cannot equal 0. That's one thing. I'm just going to kind of circle it so I don't forget it, but I'll come back to it in the end. 2. 2 cannot equal 0. That tells me nothing about z. 2 is never going to equal 0, so I don't even care about this one. Our last one is z cannot be 0. It's already there. So it took 2 seconds. We found the domain. We're going to come back to it in the end. That's our first thing. Questions on
So is there gonna be
domain?
a box that makes us do this first?
No, it'll just say solve the
So why
equation.
don't write that and you go through it and mark it wrong even though I got the question right?
But you skip that step.
Okay, I skipped that step, but I don't usually, when I get you graded my test, I skip many steps by combining them. Like
Right, and that's
common
okay.
sense. Z cannot equal 0.
Yeah, if it's common sense, that's fine. Just write it down somewhere.
Okay.
Just write it down to show me that you didn't forget that step. Usually, the domain comes back into play.
Okay.
So, how would you know which ones it would going to work for and which ones it's not going to work for just by looking at it?
Okay, so when I get into more complex questions like
Yeah, this is just
you're
a,
gonna need to
yeah.
know if it's -8 or +8.
Right,
Right.
exactly.
Okay, I'm just getting ahead of myself.
I promise there's a reason behind my madness. All right, so speaking of which, let's actually go through and solve it now. So it's fractions. Let's get rid of our fractions. So fractions mean divide. So in order to get rid of our fractions, just like we did on test 1, what did we do?
LCD.
Multiplied by the LCD. Perfect. So 8 over z plus 1 over 2 equals 6 over z. So multiplying everything by our LCD, which is
2Z.
2z. If it helps you to write 2z over 1, go for it. Because we're going to distribute this 2z to every single term on both sides of our equation to keep it balanced. And we're going to multiply across, so top times top, bottom times bottom. So 2z times 8,
16Z.
16z all over 1 times z,
Z.
z, plus 2z times 1, which is 2z. Of course, I'd put 2's and z's together. All over 1 times 2, 2, equals 2z times 6,
12Z.
12z, all over 1 times z, which is z. So we distributed our LCD. We found our domain. We distributed our LCD. We're going to simplify, and our fraction should go away. Which they do, so we know we did it right. If they don't go away, that means you have the wrong LCD. Go back and check your work. So it's kind of like a good checkpoint. If everything doesn't cancel out nicely, you have the wrong LCD. Go back and check your work. So we're left over with 16 plus z equals 12. Now we can just solve this like normal, getting z by itself. Subtract 16. Boom, we get z equals -4. Is it okay looking at our domain that z is -4?
Yes.
Yes, so we're done. just for our notes' sake, you don't have to do this on the test, but I just want to put a little note that works with the domains. That way, going back and we look at our notes, we remember to go back and check to make sure that it works. All right, so next example, we're going to solve the equation x plus 2 all over x plus 1 equals 1 over x plus 1. So going back, whenever it was, a long time ago, first thing, we have fractions. There's problems with fractions. That means we have to find the domain first. So how do you find the domain of a fraction? Looking at your other examples, how do you find the domain? What cannot happen in a fraction?
The denominator cannot equal 0.
The denominator cannot equal 0. Perfect, thank you. The denominator cannot equal 0. So x plus 1 cannot equal 0. Solving for x, getting x by itself. Subtracting 1 from both sides, we get x cannot equal -1. So we're going to leave that right there, come back to it in the very end. So we know that x can be any number, it just cannot be -1. So that's our first thing. Always don't forget, whenever there's a fraction, we have to find the domain first. So going through and actually solving this, there's fractions. Let's get rid of the fractions. So how do we do that?
LCD.
Multiply by the LCD. Perfect, thank you. So we're going to multiply all sides of our equation by our LCD. What is our LCD?
X plus 1.
Good, x plus 1. Our least common denominator is x plus 1. We are going to multiply, we are going to distribute that to every single term in the equation. If it helps you to write x plus 1 over 1, go for it. Because we're multiplying fractions, so we're going to do top times top, bottom times bottom, multiplying straight across. So that'll give us up top x plus 1 times x plus 2. On the bottom, we have 1 times x plus 1 equals x plus 1 times 1 all over 1 times x plus 1, which is just x plus 1. So x plus 1 times x plus 2 all over x plus 1 equals x plus 1 all over x plus 1. So now's my favorite part. Let's cancel each other out. X plus 1's go away. That means we're left with x plus 2 all over 1, which is just x plus 2, equals x plus 1's cancel out. So what's left over on the right-hand side?
1.
Just 1. Perfect. Awesome. So we have x plus 2 equals 1. Solving for x, getting x by itself. We can subtract 2 from both sides and get x equals -1.
Wait a minute.
Wait a minute, what's wrong?
Our x cannot equal -1.
Our x cannot equal -1, so what happens?
It's fake.
Not fake.
You can't do it.
We can't do it, right? So there's no solution. So we have no solution. This is what's called an extraneous solution. So we got a solution, but it couldn't work. So there's no solution.
That ain't gonna work.
So this is why we have to find the domain first. So if you would have put x equals -1, that's wrong. X cannot equal -1.
Like, I pulled that all out, and the only thing that would have worked there was -1.
Right, but if x equals -1, we would have to divide by 0. Math world blows up. Can't do that.
Yeah.
So because that's not in our domain, x cannot equal -1, we have no solution. How can I help you understand this one better? How can I help you?
So
So,
the LCD, did you multiply it on the top? That was it?
yep, because it's over 1. It's x plus 1 over 1. So whenever we multiply fractions, exactly, it just goes to the top. So it's top times top, bottom times bottom. On the bottom, we just have 1, so nothing's changing. So pretty much the LCD just went to the top of both fractions. And that helped us cancel out so that the fractions went away. We just have one line. Thank you for your question. Other questions? All right, let's try another one then. Let's try another one. So next example, solving the equation 6 over x minus 1 equals 12 over x squared minus 1. Same thing as usual. There's fractions, so we have to find the domain first. For our domain, there's fractions, so we know our denominator cannot equal 0. Our first denominator is x minus 1. So x minus 1 cannot equal 0. Solving for x, I can add 1 to both sides. And we get x cannot equal positive 1. Next we have x squared minus 1. Let's go ahead, let's factor that out. There's no GCF.
It's the difference of perfect squares.
It's a difference of perfect squares, thank you, so it makes it easier for us to factor. X squared is x times x. 1's positive, 1's negative. 1 is 1 times 1. So x squared minus 1 factors into x plus 1 times x minus 1. It's a difference of perfect squares. So x plus 1 cannot equal 0. X minus 1 cannot equal 0. We already solved that, so I don't have to solve it twice. So solving x plus 1 cannot equal 0. We can subtract 1 from both sides and get x cannot equal negative 1. So two things. X can be anything. It just cannot be positive or negative 1. So we're going to leave this up here and come to it at the very end to make sure that x is not positive or negative 1. How are you feeling so far? Is it coming back? That first one was probably a little warm up because it was probably like, what just happened? What did we do way back when? All right, so let's actually try to solve this one now. I want to rewrite it in factored form just so we can see it a little better. 6 over x minus 1 equals 12 over x plus 1 times x minus 1. There's fractions. Let's get rid of our fractions. In order to do so, we need to multiply everything by the LCD. What's our LCD?
X plus 1 is 1.
Good. X plus 1, x minus 1. Meh. X plus 1 times x minus 1 is our LCD. If it helps you to write that over 1, so that way you know you're going to multiply straight across. So basically that LCD is going to the top of our fraction, the bottom of the fraction staying the same. We are going to distribute that to every single term on both sides of our equation. So that'll leave us with 6 times x plus 1 times x minus 1 on top, all over 1 times x minus 1 equals 12 times x plus 1 times x minus 1 all over 1 times x plus 1 x minus 1. So we distributed that LCD to the top of our fraction. So now whenever we simplify, our fraction should go away. So x minus 1's cancel out in our first fraction, x plus 1 and x minus 1 cancels out in our second fraction. That means we are left over with 6 times x plus 1 equals 12. We simplified and our fractions went away, which is what we wanted. If your fractions do not go away, that means you have the wrong LCD. Go back and check your work. So now we can just solve this like usual. How do you want to solve it?
Distribute first.
Okay, we can distribute first. So 6 times x plus 1 equals 12. So distributing that 6, we have 6x plus 6 equals 12. And then we are going to subtract 6 from both sides. Uh-oh. So 6x equals positive 6. And lastly, dividing both sides by positive 6, we are left with x equals 1. Why'd you say uh-oh?
Because it equals 1.
Because it equals 1. Up here we said x cannot equal 1. So what's our answer?
No solution.
No solution. So no solution. Because it doesn't work in our domain, so there's no solution. What questions, comments, or concerns do you have for me about this one? If not, let's keep rolling. So solve the equation 1 over x minus x over 9 equals 0. First thing first is our domain. Same thing as usual. Nothing changes. Our domain. There's fractions, so we know our denominator cannot equal 0. Our first denominator is x, so x cannot equal 0. That's already solved for us, so that's good to go.
And 9 cannot equal 0.
And then our other denominator is 9, so 9 cannot equal 0. Is 9 ever going to equal 0? No, there's nothing that tells us about x, so really I don't even care about this one. That one tells me nothing. 9's not going to equal 0, so that's not a problem. So that's good to go. So our only restriction is x cannot be 0. It can be anything else. It just cannot be 0. So now going through and actually solving this thing, let's get rid of the fractions by multiplying by the LCD. So what's our LCD for this problem?
X minus 9.
Close? All right, so we have 1 over x minus x over 9 equals 0.
X and 9.
X and 9, right? Our first denominator is x, so that has to be there. Our second denominator is 9, so 9 has to be there. So our LCD should be 9x. Again, if it helps you to write 9x over 1, we are going to distribute that LCD to every single term on both sides of the equation. So first one, 9x times 1 is 9x. All over 1 times x is x. Minus 9x times x, 9x squared. All over 1 times 9, which is 9. Equals 9x times 0, 0. So we distributed our LCD. Now whenever we simplify, our fraction should go away. So I have 9x over x minus 9x squared over 9 equals 0. So our first fraction, our x, cancels out. Second fractions, 9 cancel out. So we are left with 9 minus x squared equals 0. 9 minus x squared equals 0.
Negative 1 positive 1.
What is it?
Negative 1 positive 1.
Close? You're super close.
Negative x positive x.
Super close. All right, so we need to solve this thing. We see that it's squared, so we know that we need to factor. So it's a difference of perfect squares, exactly.
Positive 3 minus
Yes, so 9 is 3 times 3. One's positive, one's negative. X squared is x times x equals 0. So we have 3 plus x times 3 minus x. So same thing like we usually do, it's just flipped around backwards, but nothing different.
Yes. I realize I have to open it.
That's why we're going over it, so it's okay. So setting each factor equal to 0, we have 3 plus x equals 0, and we have 3 minus x equals 0. Solving each one separately to get x by itself. We can subtract 3 from both sides and get x equals negative 3. Before I do anything, is it okay that x equals negative 3? Yes, as long as x is not 0, we're good. X can equal negative 3, so that's one answer. Over here, we have 3 minus x equals 0. How would you get x by itself? Subtract 3?
Subtract 3.
Okay. So 3 is positive, so to get rid of that 3, we can subtract 3 from both sides. So we have negative x equals negative 3,
Then divide by negative 1.
and then divide both sides by negative 1 to get rid of that negative. Perfect, thank you. And we are left with x equals positive 3. Is it okay that x equals positive 3?
Yes.
Yes, as long as x is not equal 0, this is good. Boom, we have 2 answers. So in my math lab, x equals negative 3, comma, positive 3. Is our final answer. Our final answer. As we're going through these examples, it should be getting easier and easier and easier because you should know what to expect and know what steps are coming up. It's the same steps over and over and over. So it's going to be the same steps over and over again. So before we go to this next example, how could I help you? What questions do you have? All right, let's try another one. So solve the equation 4 over a minus 3 plus 3 over a plus 3 equals 5 over a squared minus 9.
Let's get rid of that difference of perfects.
Okay, let's go ahead and let's factor it then. So a squared minus 9, what do you notice about it?
Difference of perfect square.
Difference of perfect squares. So I know a squared is a times a. One's positive, one's negative. 9 is 3 times 3. Aye. So that factors down into a plus 3 times a minus 3. So we see what's going on in our denominators. So now let's go ahead and let's find that domain first. There's fractions, so we know our denominator cannot be 0. Our denominators are x minus 3, cannot be 0. X plus 3 cannot be 0. A plus 3 is already there, so I don't need it twice. A minus 3 is already there, so I don't need it twice. So we have a minus 3 cannot be 0, and a plus 3 cannot be 0. Solving each one separately, we can add 3 to both sides and get x equals positive 3. Or I'm sorry, a cannot equal positive 3. I know. And then a plus 3 cannot equal 0. We can subtract 3 from both sides and get a cannot equal negative 3. So we know a can be anything. It just cannot be positive or negative 3. It cannot be positive or negative 3. So I'm going to rewrite my question in factored form so that we can kind of see it out a little bit better. So we have 4 over a minus 3 plus 3 over a plus 3 equals 5 over a plus 3 times a minus 3. So now let's actually go through and solve it. So in order to get rid of our fractions, we know we're going to have to multiply by the LCD.
A plus 3.
Perfect. So we know a minus 3 has to be there. We know a plus 3 has to be there. A plus 3 is already there, so I don't need it twice. A minus 3 is already there, so I don't need it twice. So a minus 3 times a plus 3 is our LCD. And we are going to distribute, we're going to multiply that to every single term on both sides of the equation. So remember, it's over 1, so basically that a minus 3, a plus 3 is just going to the top of each fraction, and the bottom of our fraction staying the same. So 4 times a minus 3, a plus 3, all over a minus 3, plus 3 times a minus 3, a plus 3, all over a plus 3, equals 5 times a minus 3, a plus 3, all over a minus 3 times a plus 3. So our LCD went to the top of every single fraction. The bottom stayed the same. So now whenever we cancel stuff out, our fraction should go away. So a minus 3's cancel, a plus 3's cancel, and then both a minus 3 and a plus 3 cancel out. So we're left with 4 times a plus 3 times a minus 3 equals 5. So now we have a single line equation where we can solve this normally, so to speak. So what would be our first thing to do to get a by itself to solve for a? Yep, distribute, thank you. So distributing the 4, distributing the 3, we're left with 4a plus 12 plus 3a minus 9 equals 5. Oh boy, the a's and the 9's are going to look the same. There we go. So we distributed. Now what? Combine like terms. I'm going to bring this over here. So combining like terms, I have 4a's plus 3a's, which will give us 7a's. And then we also have 12 minus 9, which will give us plus 3, equals 5. Now solving, we're still combining like terms. We can go ahead and subtract that 3 from both sides and get 7a equals 2. Last but not least, getting a by itself. Help me out. What should we do?
Divide by 7.
Divide by 7. So we are left over with a equals 2 over 7. 2 over 7 cannot be simplified. There's no factors that 2 and 7 have in common. Is it okay that a equals 2 over 7? Yes, as long as it's not positive or negative 3, which it's not. So our final answer is a equals 2 over 7. A equals 2 over 7. You know what's coming. What questions, comments, concerns do you have for me, please? How could I help you understand this better?
Polynomials are coming.
Sir,
I can imagine that polynomials are coming.
we're doing polynomials now.
Or trinomials.
You may be onto something. Ready for the next one?
Flip the page. Oh, there's a trinomial.
Flip the page. We have 2 examples left for this section. Let's knock them out. So same thing like we've been doing this whole time. Nothing's going to change. 1 over x minus 5 minus 5 over x plus 3 equals negative 4 over x squared minus 2x minus 15. So, a couple things. Let's go ahead and let's factor this x squared minus 2x minus 15. So a little side note. We're going to factor x squared minus 2x minus 15. Our first step in factoring is to find a GCF, but there's nothing that all 3 terms have in common, so no GCF. Our a value is 1, b is negative 2, and c is negative 15. So we're looking for 2 numbers that multiply together to give us a times c, which is negative 15. And the same 2 numbers to add together to give us b, which is negative 2.
Negative 5, positive 3.
Perfect. Negative 5 and positive 3. That way negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Because a is 1, thankfully we don't have to factor by grouping. We can use our shortcut and go straight to our factors. So we have x minus 5 and x plus 3. So we know this first fraction is really x minus 5 times x plus 3. Hey, wouldn't you know, there's already x minus 5 and x plus 3 there.
It's done.
So we know what our denominators are. Let's go ahead and let's find our domain first. There's fractions, so we have to find the domain. There's fractions, so we know our denominators cannot equal 0. Our first denominator is x minus 5. so x minus 5 cannot be 0. Our next denominator is x plus 3, so x plus 3 cannot equal 0. Our last denominator is x minus 5, which is already there, so I don't need it twice, and x plus 3, which is already there, so I don't need it twice. So all we have to really solve for is x minus 5 cannot be 0, and x plus 3 cannot be 0. Solving each one separately, we can add 5 to both sides. So x cannot equal positive 5. We are subtracting 3 from both sides. So x cannot equal negative 3. So two things we have to look out for. X cannot be positive 5 or x cannot be negative 3. Anything else, just not those two numbers. We found the domain. We're going to leave that right there, come back to it in the very end. Leave that right there and we'll come back to it in the end. So now let's actually try to solve this thing. I want to rewrite it so that way it looks a little better. 1 over x minus 5 minus 5 over x plus 3 equals negative 4 over our factored form of x minus 5 times x plus 3. We need to get rid of the fractions. We do so, fractions mean divide. So in order to get rid of them, we're going to do the opposite. We are going to multiply by our LCD. So going from left to right, we know x minus 5 has to be there. We know x plus 3 has to be there. Our last one, we have x minus 5, which is already there, so we don't have to write it twice. And x plus 3, which is already there, so we don't have to write it twice. So our LCD should be x minus 5 times x plus 3. If it helps you to write it over 1. So that way we know whenever we distribute our LCD to every single term on both sides of our equation, it's only going to go to the top and the bottom's going to stay the same because the bottom's over 1. So distributing x minus 5 times x plus 3 times 1 all over 1 times x minus 5 minus 5 times x minus 5 times x plus 3 all over 1 times x plus 3 equals negative 4 times x minus 5 x plus 3 all over x minus 5 times x plus 3. So basically our LCD went to the top of each fraction and the bottom stayed the same. So now we should be able to cancel out. Everything should go nicely. So x minus 5s are canceling, x plus 3s are canceling, and both x minus 5 and x plus 3 cancel out. So we are left over with x plus 3 minus 5 times x minus 5 equals negative 4. So now we can solve it just like we would do a normal equation. Outside of our first parentheses is nothing but a positive 1. So it's going to stay x plus 3. Then we have x plus 3 minus 5 times x minus 5 equals negative 4. So we can now distribute this negative 5. So negative 5x plus 25 equals negative 4. X plus 3 minus 5x plus 25 equals negative 4. Combining like terms, 1x minus 5x will give us negative 4x's. We then have 3 plus 25, which is plus 28, equals negative 4. And then keep going. Let's subtract 28 from both sides. We're left with negative 4x equals negative 32. Finally, last but not least, getting x by itself, we can divide both sides by negative 4. And we are left over with our final answer of x equals negative 32 divided by negative 4, which is positive 8. Is it okay that x equals positive 8?
Yes.
Yes, as long as it's not positive 5 or positive 3, which it's not. So boom, final answer. X equals 8. So last one, same concept over and over and over. Find the domain, multiply by the LCD, and then solve it like normal, going back and checking our domain. So before we do that last one, questions, comments, concerns for me? So if not, let's knock out this last one. So we have 1 over x minus 2 minus 2 over x squared minus 2x equals 3. Let's go and let's factor first. It helps us find the domain. Let's factor. So x minus 2, there's no GCF. Everything's factored. X squared minus 2x. GCF is x. Good. You can factor out that x, and we're left over with x minus 2. Then that equals 3. So first, finding our domain. We know that our denominator cannot equal 0. So x minus 2 is our first denominator. That cannot equal 0. Then we have x cannot equal 0. Then we have x minus 2, which already cannot equal 0, so I don't have to do it twice. So you have x minus 2 cannot equal 0, and x cannot equal 0. Solving each one separately, we get x cannot equal positive 2, and x cannot equal 0. So we're going to leave those there, come back to it in the end. X can be anything. It just cannot equal 0 or 2. Super important. Whenever you write this, you have to write cannot equal. So don't forget that line through the equal sign that says cannot equal. Super important. So let's go ahead and let's try to solve this. So I'm going to rewrite it just so it looks better in factored form. We have 1 over x minus 2 minus 2 over x times x minus 2 equals 3. We want to get rid of the fractions. We do so by multiplying by our LCD.
X minus.
Good, x times x minus 2. If it helps you write it over 1, go for it. That's our LCD that we are going to distribute to every single term on both sides of our equation. So going from left to right, x minus 2 has to be there, x has to be there, x minus 2 is already there, so I don't need it twice. So our LCD is x times x minus 2. So distributing that, we have x times x minus 2 times 1 all over x minus 2 minus 2 times x minus 2 all over x times x minus 2 equals 3 times x minus 2 all over 1, but I don't need to really write that. I guess I can if you want. Either way, there's nothing on the bottom, so I don't need to really even make a bottom. So whenever we cancel everything out, our fractions should go away. So our first fraction, x minus 2's cancel. Our second fraction, x and x minus 2 cancel. Our third fraction is over 1, so there's really nothing even on the bottom anyways. So we're left with x minus 2 equals 3x times x minus 2. So we now have a single line equation that we could solve like normal. Yeah, let's get rid of the parentheses. Let's distribute. So 3x times x minus 2, let's distribute that. We'll be left with x minus 2 equals 3x times x is 3x squared. 3x times negative 2 is minus 6x. So I see it's x squared. Let's go ahead and let's combine like terms. And I know whenever it's x squared, I need to have it, it's a quadratic. So I need to have it in standard form, which is set equal to 0. So let's subtract this x from both sides. While we're at it, can I also add that 2 to get it set equal to 0? Can I do two things at once?
Yes.
So we're left with 0 equals 3x squared. Negative 6x minus 1x is negative 7x plus 2. So we had to, it's a quadratic, so we had to put it into standard form, which is ax squared plus bx plus c equals 0. When we have quadratic forms, quadratic equations in standard form, how do I solve this? How do I get x equals? What's our favorite F word? The real F word in this class. No, not FOIL. What?
Formula.
Okay, we can use a quadratic formula. What else? When in doubt, what do we do? Factor. When in doubt, factor it out. Pretty good one.
Let's go look at his word for it.
Yeah, not FOIL. Good one. Haha, very funny. All right, so 3x squared minus 7x plus 2. Let's go ahead and let's factor this. Our first step in factoring is GCF. Is there anything that 3x squared minus 7x plus 2 have in common? Nope, so no GCF. Our A value is 3, B is negative 7, and C is positive 2. So two numbers that multiply together to give us 3 times 2, which is 6. And the same two numbers that add together to give us B, which is negative 7. Negative 6 and negative 1. Negative 6 times negative 1 is positive 6. Negative 6 plus negative 1 is negative 7. Unfortunately, A is 3. A is not 1, so I have to factor by grouping. So we're going to use the numbers in our blanks to split up that middle B term. A is not 1, so we must factor by grouping. So we have 0 equals 3x squared. Instead of that middle negative 7x, we're going to use the numbers in our blanks. So negative 6x minus x plus 2. So this is all from last test. We now have 4 terms. We can factor by grouping. So group the first 2 together, group the last 2 together. Looking at our first 2 terms, 3x squared minus 6x, GCF, 3x. So I can factor or divide out a 3x from both terms. And we're left with x minus 2. Looking at our next 2 terms, I have negative x plus 2. I know I want x plus 2 to be left over. I know I want x minus 2 to be left over, so what should I factor out as a GCF? Negative 1. Factoring out negative 1, we are left with positive x minus 2. So coming up over here, we know we did something right because they are both x minus 2. So that'll be our GCF. That's coming out front. So 0 equals x minus 2. Taking out those x minus 2's, we're left over with our other factor of 3x minus 1. So we have 0 equals x minus 2 times 3x minus 1. We now have it in factored form. Last step, just setting each factor equal to 0. So x minus 2 equals 0, and 3x minus 1 equals 0. Solving each one separately, I can add 2 to both sides, and we get x equals positive 2. Is it okay that x equals positive 2?
No.
Sure? Yeah. No, x cannot be negative 2 because of our domain. So this one can't work. No. Not in our domain. So x cannot be positive 2. Let's try our other one though. 3x minus 1 equals 0. Let's add 1 to both sides. And we get 3x equals positive 1. And then dividing both sides by 3, x equals 1/3. Is it okay that x is 1/3?
Yes.
Yes, looking back at our domain, x cannot equal positive 2 or 0, so it's okay that x equals 1/3. That's our only solution.
My phone goes everywhere.
So this is Module 8, Homework 1 notes.